Okay, welcome back to Real Analysis. We have been, up until now, spending some time constructing the real numbers. And today what I'd like to do is to talk about some further extensions of real numbers. In particular, you want to spend a little bit of time on complex numbers. And then in the second half of the lecture, we'll begin talking about the principle of induction, which is a very important proof technique. And as you'll see, it has its foundations in a particular axiom for the natural numbers. Okay, so let's begin. So last time we mentioned that the real numbers were they could be defined very naturally in terms of cuts. These are Dedekind cuts. The construction basically involves constructing real numbers from the rational numbers. But we also saw that the real numbers were characterized by some properties, right? So that real numbers are basically the only complete ordered field with a particular property, the least upper bound property. Okay. So today I want to talk about a few extensions which are often convenient, that are not necessarily going to enjoy all the nice properties of real numbers, but they're sometimes useful. So the first thing I want to mention is something called the extended reals. And this is more a convenience than anything. I'll define the extended reals, and sometimes it's signified with R with a bar over the top. Remember this colon equals, I'm going to use to mean as a definition. I'm going to define this to be the reals together with a couple of extra points. Okay? So as an abstract set, it's the real numbers together with two extra points, which I will denote by minus infinity and plus infinity. Okay? You can't stop me from making a definition like this. Okay? Now, of course, it would be a rather pointless definition if I didn't also tell you how these creatures work with the structure that's already on R, the one we're used to associating with it. So as a set, it's this creature, but we actually can order this set. So R already has an order. The usual one on R, and then together with telling me how minus infinity and plus infinity behave. So where do you think I'm going to place these things in the order that's on R? Yeah, at the very ends. How about for all x in R, I'll just demand that x be whatever it is, if it's one of the real numbers, less than plus infinity and bigger than minus infinity. Okay? The usual order on the reals, but then together with this. Okay? And now you might say, well, what about an arithmetic? Okay? Is there can I extend the arithmetic on the reals to the extended reals? And the answer is, yeah, you can try. And so here's at least a partial attempt at an arithmetic. Maybe we'll say that there's the usual addition on real numbers, but if you ask me to add a real number to positive infinity, then I should get what? Yeah, positive infinity, right? And how about if I add minus infinity to x, I should get what? Minus infinity, okay. Certainly can't stop me from making that definition. Everything, is okay for the most part there. And you can make a few more other definitions as you like, right? For instance, if x is bigger than 0, we'll define x times positive infinity to be positive infinity. And if x is less than 0, x times positive infinity be negative infinity, etc., etc. Okay, you can basically do things in the natural way. Yes, Jenny, question. Oh, yes, very good question. Yeah, and there's a reason that you can get so far, but you can't finish all these definitions without running into some problems. And so there are a few things you leave undefined. I guess there are a few things you could do. You could still do. I mean, there are a few more things I didn't mention. You could define x divided by plus infinity to be 0. Okay. But there are some things that you can't, so etc. There's some things that you'll have problems with. So for instance, 0 times plus infinity. Well, you can see you might begin to run into problems if you make this kind of definition. 0 times plus infinity should be what? It's not well defined. Okay. Or another thing you might have a problem with is how about plus infinity plus minus infinity? What should that be defined as? No good way of doing that. Okay, so this thing is, the upshot is it's not a field. Okay, it's a set with some structure, but it's not a field. Okay, but why do we care about thinking about the extended reals? Well, it's convenient sometimes, right? So why care? It's convenient. One thing that it ensures, so for example, if you tell me to take the supremum of a set, well, the set, sets the set, in this case here, every set is going to be bounded, right? It's going to be bounded by plus infinity. Every set will have a supremum, okay? So every set in our say subset of R bar, the extended reals, has a supremum, or if you like, an infimum as well. Now, of course, possibly the supremum could be plus positive infinity. That's just another way of saying the set is unbounded if its supremum is positive infinity. Okay. If it's bounded, then of course it's going to have a supremum where? In the real numbers, the usual reals. Okay? But it's convenient. So sometimes you will see this kind of notation, right? An unbounded set, you'll see the supremum of a set might be plus infinity. Okay. So that's the main reason we care about the extended reals. Okay, what are some other structures that are built around the real numbers, having the real numbers as a foundation? Well, here's another one. How about Euclidean space, r to the k? So the way I think about r to the k is I'll think of it as ordered k-tuples. So that's basically a collection, a multiple collection, it's a tuple of k things, right? So x1, x2 through xk. It's an ordered collection. So the order matters. So 1, 2, 3, 4, 5, 6, blah, 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 k is different than 2, 1, blah, 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 k, right? And I'm just demanding that each of these creatures, each of the xi's are in R. Okay? So it's collections of real numbers. Okay. Once again, this is a set, and it becomes more interesting when you give it a structure. Okay? So what's one of the first things